Number 27, we're supposed to graph y equals negative 5x plus 3 with the given domain x is less than or equal to 0. So this is a fancy one. If they give us a fancy domain, we're going to have a fancy graph. This tells us that the graph is going to have to stop at one point. I can only pick x values less than or equal to 0. So if I make a table of values, and it's nice because they've already solved the equation for y, so I just have to plug and chug my x values. I have to pick x's that are less than or equal to 0. We always want to pick the endpoint first. So start by picking 0. If I plug in 0, negative 5 times 0 is 0, plus 3 makes 3. Now I have to pick values of x less than or equal to 0. So less than 0, maybe I pick negative 1 and negative 2 just to keep the numbers nice and tiny. If I plug in a negative 1 for x, negative 5 times negative 1 is a positive 5, plus 3 makes 8. If I plug in negative 2 for x, well, negative 5 times negative 2 is a positive 10, plus 3 makes 13. Uh-oh, I'm going to go off the graph. That's right, we'll just move that and that. If I start plotting these points, sometimes what I like to do is put a big old stop dot at my endpoint. Again, the endpoint is going to be when x is 0. When x is 0, y is 3. So I'm going to make a big old stop sign right there for myself. What are some other points in the graph? Negative 1, 8. Negative 2, 13. It's going to be up there somewhere. I don't quite see it. But again, this wouldn't be just a straight old line. It stops here and it goes forever in this direction. So this would be a ray. I can't continue that in this direction because if I did that, I'd be using positive x values. 1, 2, 3. And they said I can only pick negatives. So I can't have that part of the graph. Graph looks like that. The range is not just 3, 8, 13. Those are 3 y values we hit, but we also hit 4 and 5 and 6. Basically, you want to look for what's the endpoint. The endpoint is 3. The y value is 3 right there, and I go up from 3. How do I describe all the values at 3 or above? We'd say all the y's. We hit all the y's greater than or equal to 3.